Alright, we're gonna have another session of mathematics. Grade 11s. We're gonna do functions. We're gonna do specifically a continuation of hyperbola functions. Hopefully we'll get into exponential functions, and then that will lead us to gravitating very nicely away to Never Never Land. Right, so hello. Alright, hello guys. So I hope we are well, I hope we are good, I hope we are well. So I'm actually going to be taking some time I'm going to take some time and actually do a exam type question for hyperbola functions. I've been doing hyperbola functions, so today I'm specifically going to be looking at this question. Okay, this question, I hope you guys can see it. It's a grade 11 question, so it's saying f of x is equal to negative 3 over x minus 2 plus 1. We're going to look at 2.1. We're going to see how we can go about calculating the coordinates of the y-intercept of f, calculating the coordinates of the x-intercept of f, how we sketch this function, clearly showing our asymptotes and the intercepts with the axes, how to write down the range, how another function of h, obviously different from this function, is formed by translating f 3 units to the right and 4 units down. We're going to look at that, and how do we write down the equation, the new equation. Then we're going to look at this question which says for which values of x is h of x less than or equal to negative 4. And then last but not least, we're going to look how do we go about determining the equations of the asymptotes of this particular function. You see, this is k of x, and it's 3x minus 5 over x minus 1. This hyperbola form, this rational form, is the form of the hyperbola that maybe some of us are not familiar with, because what do we know as the general form of a hyperbola form? We usually know that there is one isolated value at the top, which is usually a, but you can see here there's a binomial over another binomial. So we're going to look at those specifics and those details, and then hopefully we'll be able to make some conclusions. I want to also look at some interpretation questions that have to do with functions, and we'll look at that immediately after I'm done with answering this particular question. So let's note there, we are given, what are we given? We are given f of x. And this f of x, what are we told about it? It's equal to negative 3 over what? X minus 2 plus what? Plus 1. That is the function. F of x is equal to negative 3 over x minus 2 plus 1. So we're going to check on how do we go about sketching that function first and foremost. So let us proceed, let us go forth, and let us see how we can save ourselves in this situation. The first question says calculate the coordinates of the y-intercept of f. So we are told to calculate the coordinates of the y-intercept. Y-intercept, what does that mean? It means we let x be equal to 0. Let's never forget that. I'm sure now we are getting to a place where we are mastering this conceptual application, that if they want the y-intercept, that simply means we are going to let x be equal to 0 in the function. So what do we do? In the place of x, and in the place of x here, what do we substitute? 0. So we're going to say f of 0 is equal to negative 3 over what? 0 minus 2. You see? So how basic and simple is that? Just simply substituting 0 in the place of x where the function is. So in the place of x we substitute 0, and in the function itself we substitute 0 plus 1. And then what do we do after that? We simplify our answer. So negative 3 at the top, 0 minus 2, guys, is equal to negative 2 plus the 1. All right, obviously now one will be able to grab their calculator. Okay, negative 3 divided by negative 2, that gives you a positive 3 over 2 plus 1. Okay, and then ultimately and finally, what do we get? We're able to get an answer, which if you punch into your calculator, you'll be able to get an answer of 5 over 2. All right, so this here is our y-intercept. Y is equal to 5 over 2. And remember, in the question, they don't want just the y-intercept. They want the coordinates of the y-intercept of f. Now, if they say the coordinates, take note of the wording. We need to make sure that we write down our answer in coordinate form. Because if they had asked for the y-intercept, only just y-intercept, then it would have been okay to leave our answer as y is equal to 5 over 2 and then move on to the next question. But seeing as though they said they want the coordinates of the y-intercept of f, then it becomes important for us to actually write down our answer as coordinates. Remember, what did we do? We let x be equal to 0. So therefore, remember, in coordinate form, x is here on the left hand side of our point. So we are going to write in the place of x, remember we let x be equal to 0, we're going to write x as 0. And then our y value will be 5 over 2. So that means the coordinates of the y-intercept are 0, and this here stands for and, 0 and 5 over 2. So then we are done and dusted with the coordinates of the y-intercept. Thank you, Y and Denny. Really appreciate the gift there. Okay, so answer the first question. What is the y-intercept of f of x? What are the coordinates? Because remember, the question specifically said the coordinates of the y-intercept. Let's go and check what the second question asks us. The second question says calculate the coordinates of the x-intercept. The what? The coordinates of the what? Of the x-intercept. So once again, we must be clear about what they want. They want the coordinates. They don't want the x-intercept, just purely the x-intercept. Because if they're asking for that, we know what we need to do. We need to let y be equal to 0. Then substitute that into the function. Remember, f of x in its entirety means y. So in the place of f of x, we replace f of x with 0. Then we solve for x. After getting the value of x, because they want the coordinates, then it means that we are going to have to write the coordinates of the x-intercept, not merely the value of x when we let y be equal to 0. So let's go ahead and do that. Go to the function, means in the place of f of x, we are going to say, since they want the x-intercept, we know that we let y be equal to 0. So we are going to replace y, or f of x, in its entirety, because remember f of x means y and y means f of x. So we're going to substitute in the place of f of x 0 minus 3 over x minus 2 plus 1. And the easiest way, guys, to solve for x for this type of hyperbola function, we take the one which transposes it. It becomes negative 1 on the other side. It's quicker that way. Then we do what? We cross multiply the x minus 2, which is like the same thing as actually going ahead and finding the LCD, the restriction, and then multiplying the left and the right hand side by x minus 2. So when we cross multiply, we get minus into x minus 2 is equal to negative 3. We distribute the negative, we get negative x plus 2, which is equal to negative 3. Then we isolate the variable x. So we transpose the 2, minus 3 minus 2. Remember, when the plus 2 goes over to the other side, changes to negative. We get negative x. Negative 3 minus 2 gives us negative 5. But remember, we want the value of x, so we divide both sides by negative 1, so that ultimately we can get the positive value of x, and negative divided by negative gives us a positive, so we have x is equal to positive 5. But remember, we don't want the x-intercept, the value of x, but we want the coordinates of the x-intercept. So remember, what did we let y be? 0. So that means in the place of y, we write 0 for our coordinates, and then x is 5. So therefore, our coordinates are 5 and 0. Right? So I hope we understand this concept now of x-intercept, that whenever they ask us to find the x-intercept, we let y be equal to 0. We substitute into the function itself. In the place of y, we write 0. Then we solve for x. How? We transpose the positive 1, it becomes negative 1. We cross multiply x minus 2 so that it is multiplied with negative 1. And remember, since it's x minus 2, it's a binomial. When it is multiplied by negative 1, remember, we actually write the binomial inside the bracket so that the negative 1 can be distributed. Negative times a positive x gives us negative x, and negative 1 times negative 2 gives us positive 2. Okay, negative times positive gives us negative, and then negative times the negative gives us a positive. Then we solve for x. We get x is 5, and we write the coordinates. Since we let y be 0, that means 0 is y, and then leg x, our value for x is 5. Okay, let's go on to the next question. The next question, 2.3, says sketch the graph of f, meaning this function, clearly showing the asymptotes. Oh, there is a $1 million word, the word asymptotes. Remember, when they say asymptotes, it means that they want us to actually write down or draw in the asymptotes in our function. They must be made visible so that we can see them and that we can be able to actually sketch our function within the boundaries of the asymptotes in the correct quadrants. And the intercepts with the axes. So what's nice is that we've already found the intercepts with the axes. It's just a matter of making sure now that we sketch and actually mark those points of the intercepts with the axes. Then it says we just need to do that, sketch the function. So let's go and sketch the function. So what we do is we draw our beautiful, nice what? A Cartesian plane. There it is. That's our Cartesian plane. Then before we even go ahead and draw anything on that Cartesian plane, from the previous questions that we've answered, we were able to get the y-intercept, the coordinates 0 and 5 and over 2, and the x-intercept, the coordinates, which is 5 and 0. But we know that before we sketch any hyperbola function, we need to make sure that our planning has been done. In other words, we look at the function and we look at the numerator value of the rational fraction. So there's -3 in the numerator. That is the value of a, our parameter a, which basically helps us to get the, what does it help us understand? The parameter helps us to be able to understand the position and the shape of our function. So a is equal to what? To -3. That means a is less than 0. Okay, so a is equal to -3 means a is less than 0. So what are we expecting? That where the asymptotes are, we are expecting to have our function located in the second and the fourth quadrant. That is the plan. All right, then secondly, we need to write down our horizontal asymptote and our vertical asymptote. So let's start with our vertical asymptote, and we just use the I just use the letters VA because it is an appropriate acronym for vertical asymptote. VA, vertical asymptote. So the vertical asymptote can be written by looking at the expression in the denominator, which is x minus 2. The inverse of the constant term gives us the equation of the vertical asymptote. So that x minus 2, all we do is we equate it to 0. And when we solve, we get the inverse of -2 because the -2 is transposed. So the equation of the vertical asymptote is x is equal to 2. Then we go to our horizontal asymptote. Horizontal asymptote is simply what? It is the value, it is the constant term value, all right, that is not included in the rational fraction. The constant term, that is a standalone constant term. So as it is, we say y is equal to 1. So that is the vertical asymptote and the horizontal asymptote, okay, for our grade 11 and grade 12 learners to be able to understand, because that's relevant to them. Then we can draw in the asymptotes on our Cartesian plane. So x is equal to 2 on the Cartesian plane is on the positive side of the x-axis. So we have 0, which is the origin, 1, 2. So let's just make sure that we locate where 2 is. And then what we do, since it's x is equal to 2 and we know that this is a vertical line, vertical asymptote means vertical line, we go ahead and we use our ruler and we draw a broken vertical line and we label it x is equal to 2. That's our vertical asymptote. We've sketched it. Okay, then we go and sketch our horizontal asymptote. A horizontal asymptote, the word horizontal means a line from left to right. That's a horizontal line. So we go to y is equal to 1. We check where is 1, where y is 1, somewhere here. We mark it. Then we sketch a horizontal line using our ruler, and that is, we label it y is equal to +1. So there you have it now, the quadrants of our function. This is the first quadrant. The first quadrant has the boundaries of the asymptotes, actually making sure that this first quadrant is marked off. This is the second quadrant, all of it here marked off. This is the third quadrant from the asymptote, okay, and then the fourth quadrant, okay. But we know from our plan that since a is negative, less than 0, we are expecting to locate or find the function of the hyperbolic function in the second and the fourth quadrant. So we are expecting a function here, the arm, and another functional arm here. So let's go to our x and y intercepts that we had found when we had been asked the questions to find the x and the y intercept. So our let's start here. Our y intercept is 0, 5 and over 2. Now 0 and 5 over 2, where is it? Remember, 5 over 2 if we use our calculator, decimal form, we know 5/2 is actually equal to 2,5. So this here is actually 2,5, which means it is after the y value, which is 2, and before the y value, which is 3. So let's look at 2,5 here on the y-axis. Okay, we have 1, then 2. 2,5 would slightly be here. We just label and mark as per our function. That is 5/2. That is one of the arms. That is one of the points where the arm in this quadrant will pass through. So already you see the shape of that arm. You are anticipating that it will pass through like that. Okay, so for now, let's just mark the points. Let's go and check out the next one that we have from our function. We got our x-intercept, which is 5 and 0. So that means where x is 5 and where y is 0, which is exactly on the x-axis. So this is beautiful that this 0 for y means on the x-axis. Okay, for y. This y value, it means on the x-axis. This x value, which is 0. So whenever x is 0, then here we say not on the x-axis, but on the y-axis. Okay. So when x is 0, it means on the y-axis. When y is 0, it means on the x-axis. Okay. So this 5 and 0, where x is equal to 5 and y is equal to 0, meaning on the x-axis, is located, remember, this is 2, 3, 4, 5. So 5 is expected to be located somewhere here. Okay. All right. Okay. And what I then do for myself, because I want to see the curve and the shape, I can see there's one point of my arm in the it's one point for the arm in the second quadrant. So let me find an additional point so that I can be able to see the curve in this particular quadrant. Okay, so we can go ahead and choose a specific point. Let's say where x is -1. We just go and substitute that -1 in the place of our function here. -1 minus 2 gives you -3. So we have -3 over -3 plus 1, which means this is +1 plus 1, which is equal to 2. We could use this, guys, just use the calculator to basically find what the corresponding y value would be. If x is equal to -1, that means we get, when we substitute -1, we get a corresponding y value, which is 2. So when x is -1, y is +2, which is slightly after 1, but before 5/2. So where is this point? It is here. Where x is -1, y is +2. So we are here. And so what's beautiful is that all you simply do is you go and sketch your functional curve. It's a smooth curve, guys. Draw an arrow there, draw an arrow here. Remember that vertical asymptote. Okay, just write -1 and 2 for our point here, and then obviously this is the y-intercept. So at least when you have 2 points like that, you can see the shape of the arm. Okay, from one point to the next, you can at least see the shape of that arm, that it is a smooth curve, approaches the vertical asymptote but never touches it. Then the curve, as it curves towards the horizontal asymptote, it also approaches this asymptote but never touches. Okay, so let's go this side to sketch the arm in the fourth quadrant. Okay, so we already have a point there, 5 and 0. Let's try and find a point here, let's say in between, and let's say the point 3. So let's go there and substitute 3 in the place of x. 3 minus 2 is 1 for the denominator. -3 divided by 1 is actually -3. And then -3 plus 1 gives you -2. So that means when x is 3, y is -2. Okay, so we are meeting here. here is the specific point where we are meeting. Okay, so what you're gonna see then is that when you draw your sketch graph, this is what you are anticipating. Okay, guys, I hope you're seeing this, eh? So this here is this curve, smooth as can be, guys, smooth as can be. Not straight lines connected, no, it's a curve, guys, it's a curve, nice curve. Approaches the vertical asymptote, never touches it. This one, this side, approaches the horizontal asymptote, but never touches it. Okay, and all we simply do is that after making sure that the x-intercepts clearly labeled, that's 5. The points, the extra points that we get, 3 and -2, making sure that those are labeled. We have labeled the horizontal asymptote, y is equal to 1. We have labeled the vertical asymptote, x is equal to 2. And then obviously the points here, the y-intercept, which is 5/2, there we have it. And then the points that are additional that help me with the curve, -1 and 2. So our sketch is done and dusted. It's beautiful, it looks good, and truly it really conforms to what we expected in our plan, that if a is equal to -3, means a is less than 0, means that the function will be found in the second and the fourth quadrant. Okay, and there you can see it. It's truly in the second and the fourth quadrant of the asymptotes. Okay, any questions, guys, that people have there as you are sitting there, you're listening and you're like, I didn't know that. Hopefully you guys can share your feelings, thoughts, impressions, attitudes, and delights and joys in the comment section. And yes, please guys, it's always nice when people can comment or request. You can request if you want to. If you have specific questions, you'd like to use your beautiful audible voice and voice out things instead of typing them, you're more than welcome to do that too, and we can see if it is possible. The next question. Okay, so this has been done. We sketched the graph of f, clearly showing the asymptotes and the x-intercepts with the axes. So we are happy. Question number 2.4, write down the range of f. The range. What does this question mean? What is the range? Range simply means the possible y values where the function will exist. The possible y values where the function will exist. So the question you need to ask yourself is, where does the function exist? And then when you look at range, you are looking from the bottom to the top. Started from the bottom, now we're here. Started from the bottom, now we're here, here, here. Started from the bottom, now we're here, here. Started from the bottom, now we're here, here, here. The range is from the bottom to the top. That's the y value. So we're looking at the function from the bottom to the top, and we are checking, where does the function exist from the bottom to the top? Does it exist everywhere? Does it possibly potentially have restrictions somewhere? Where does it exist? So that is the range. So let's look at the function and check. We are looking at the function, we are starting from the bottom, and what we do is we go up, 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 and we are asking, where does it exist? Exist, 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 exist. Then it gets to the asymptote. Does not exist. Where does it not exist? Where y is equal to 1. It does not exist. Then above that asymptote, exist, 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 and it exists infinitely all the way, right, to positive infinity. And then here, this is the only place where the function doesn't exist. It is on the horizontal asymptote. So when we write the range of the function, we say y is an element of real numbers, but y cannot be 1. Y is an element of real numbers. In other words, the function exists everywhere from the bottom to the top, with the exception of y being 1. Y cannot be, this symbol here, this equal sign with a vertical slash, means cannot be. So y is an element of R, meaning y is for everyone, for every real value. It's like every I usually say this is for every real value. Real values, all real values you can imagine. So y is an element of R, but y cannot be 1 because the function does not exist on the horizontal asymptote. Okay, so that is the range. That question has been answered. Range is y is an element of R, y cannot be 1. Let's say they had asked for the domain. What would we have said for the domain? Okay, so range, I'm going to just write the definition again. Range is the possible y values from top to bottom. From bottom to top, where the function exists. Then again, domain is just the opposite. So you can rewrite the sentence, and then the only thing you change, you say range is the possible x values. Domain is the possible x values. From where? From left to right. So here we are looking from left to right. We are not looking from the bottom to the top. From left to right, where the function exists. Where function exists. That is the domain. So when we write the domain, we are looking first and foremost from the left. We are moving from the left. Asymptote. Function doesn't exist. So exist doesn't exist. All the way to the right. So there's one place where the function doesn't exist, and that is on the asymptote. The function ceases to exist on the asymptote. So therefore we say, again, x is an element of real numbers. And guys, remember, the only reason why we say x is an element of real numbers is because the left, if you look at this arrow indicates that this function infinitely in that direction, approaching the asymptote but never touching it, infinitely to this direction. And this arrow indicates negative infinity. Okay, then if you come to this arm, it also goes all the way positive infinity. This arrow indicates the infinite nature of the function from left to right. To the right. Infinite nature of the function to the left. Negative infinity, that is. So therefore, when we write the domain, we are looking at the domain as the possible x values. We are moving from left because that's the x values as we move. But here, the function on the asymptote, that's vertical, does not exist. So we say x is an element of R, x cannot be 2. Okay. All right. Another question that they ask is, provide the what? The axes of symmetry, the equations of the axis of symmetry. And they're asking us for the equations. This means there's more than one equation of the axis of symmetry where a hyperbola is concerned. And roughly speaking, guys, the axis of symmetry, there are two functions, all right, of the same type, which means the axis of symmetry is a straight line that has a positive gradient and passes through the point of intersection of the vertical asymptote and the horizontal asymptote. So there's this positive direction axis of symmetry, cuts through where the horizontal asymptote and the vertical asymptote intersect, which is basically, if you were to actually write that point here, you would write it as x is what? Is 2. So we write 2 and y is positive 1. So we write it as 2 and 1. That would be the point of intersection of the vertical and the horizontal asymptote. 2 and 1. Okay. Hopefully you are feeling that. Now, you want to write the equation of the two axes of symmetry. So like I said, there's this positive gradient x of symmetry which goes in this direction, and there's also a negative gradient x of symmetry which also cuts through the point of intersection of the vertical and the horizontal asymptote. So yesterday I said it is very easy to write these axes of symmetries. All you simply do, and I showed two ways of writing the axis of symmetry, and I said there's you could say the long way and the short way. So the short way that I personally love is this one. First and foremost, if we are looking at the positive gradient AOS, then we know before we even start that the gradient of that positive gradient x of symmetry is going to be without a doubt equal to 1. M stands for gradient, or sometimes they use A, instead of M. But it doesn't matter, guys, as long as we understand that the coefficient of the bracket is basically M or A. So anyways, here's what we do. We write this form: A into x minus p plus q. All right, because we are writing the the equation of the x of symmetry that has a positive gradient. Remember I said the gradient will always be equal to 1. Grade 11, grade 12, even grade 10, gradient will always be 1. So what we do is we write the 1, no problem. Since the positive gradient of symmetry, it has to be positive 1. Then inside this bracket, guys, all you simply do is you go to the denominator of the function, which is x minus 2. You take this whole thing as it is, come and plug it in here. That's it. Take the entire expression there, this one, x minus 2, come and plug it into the bracket. Then you take the constant value plus 1, you come and replace it with the q. And then after that, all you do is you do what? Is you expand or simplify, as they would say. So when you simplify, remember the 1 into x minus 2 simply means you distribute the 1 into the x and the negative 2, you get x minus 2. And then this constant term is there to be added to the negative 2, the constant. Then all you simply get, minus 2 plus 1, you get an equation of the axis of symmetry. The first one, the one that has a positive gradient, which is x minus 1. Guys, this is so straightforward. Okay, it's so straightforward. Just use that form. You substitute the positive gradient in the place of a. You take this expression is replaced by the expression in the denominator. Someone else might be sitting there and asking, so what if they did not give me the function and I have the graph as it has been sketched and I have the equation of the vertical asymptote? How would I know what to do here in the x minus p? Guys, all you would do is you would just simply do this. You would rewrite this, take the 2 over, you transpose it, you make it equal to 0, then you know what belongs in the denominator. This here will belong in the denominator of your hyperbola function. This is also the expression that you would actually replace in this bracket. Okay, so this here is the expression in the denominator for your hyperbola function. You just substitute that there. This q value is the constant term of the hyperbola function. So all you do is you substitute the bracket and you substitute the positive 1, you distribute, you get the equation of the positive gradient axis of symmetry, which is the equation of a straight line where the gradient is always going to be positive 1. It will never be 2 or 3 or anything else. It will always be positive 1. Then we have the negative gradient axis of symmetry, and what we do, guys, is no different. The only difference here is that the gradient is equal to what? To negative 1. Okay, the gradient is equal to negative 1 because it is the negative gradient axis of symmetry. So it was always going to be negative 1, and all we do is we write the same form We substitute in the place of a, or m as it is called, we substitute -1. Then we go and take that expression, that same expression that we took in the denominator, which is x minus 2. You go and plug that in as it is. And then the q, remember the q value, you just substitute the +1 there as it is. Okay? And then all you do is you distribute. You get -x plus 2, -x plus 2 this time round, -x plus 2 plus 1, and then finally the answer is -x plus 3. So this, guys, is the equation of the axis of symmetry, the one that has a negative gradient. Very, very key. So we've just established and we've hammered in this concept once again, and I hope it's hammered in that much more, that this idea of getting the gradient, the axis of symmetry that has a positive gradient, and getting the axis of symmetry that has the negative gradient, is simply done in this way. All right, but alternatively, obviously, you can do it in other alternative ways. So guys, this is that's how we get the axis of symmetry, and I hope we are content with that conclusion. Okay, hope we are very content. Okay, all right, so yeah, that basically is that. And then I just want to venture now and answer the next question in our activity, which says another function h is formed by translating f. Here is f. Now, translation has to do with transformation of the function, movement of the graph, either up or down, left or right. You know, there's different movements of the function. Okay, and here we are told another function h, meaning h is a function that is new. How is it formed? It's formed by translating f. Remember, guys, when they speak of f, they are speaking of f of x, this function. Someone is going to ask me, where is the x if you are saying this function, this f means f of x? Guys, that's how they shorten when they relate it to a function. They look even here, another function h. We know it's h of x, guys, but they just short form, you know, the function by writing this. So another function h is formed by translating f 3 units to the right, 4 units down. Then the question is, write down the equation of h. Write down the equation of h. So let us first and foremost check what they are saying. So f is translated, h is formed by translating f 3 units to the right. Okay, so if you were to initially write this down algebraically, what does it actually mean? Okay, and I hope I can help us out here by what it actually means. This simply means the following. This simply means you are taking f of x, all right? Now, we need to understand when they say translating f 3 units to the right, 3 units to the right, that simply means, remember, if we are saying 3 units to the right, this speaks to the counterintuitive nature, all right? Because if we are saying to the right, what we understand is that we are subtracting 3. Okay, we are subtracting 3. So we say f of x minus 3. All right, and then if they say 4 units down, it means to the q value we are adding. No ways, you are crazy, sir. No ways. If you are saying 4 units down, you say we are adding. No, you are crazy, sir. Crazy, crazy, crazy. When they say 4 units down, it means we are subtracting 4. All right. So this is basically what we are saying, right? They're saying another function h is formed. So I write h of x. How is h of x formed? By translating f 3 units to the right. So I repeat, 3 units to the right. So there, for f, what are you going to do? It means we are subtracting 3. Okay. In our heads, normally we think if you're saying 3 units to the right, if you are moving, 3 units to the right, then in our head we are thinking there's addition of 3. No, guys, we are subtracting 3 because movement of left to right is counterintuitive when it comes to what we add or when do we add or when do we subtract. So we talk about the counterintuitive nature of the parameter p. Okay, so in our grade 11 syllabus, we need to understand that where the p-value is concerned, because that speaks to movement of the graph left and right. If we are saying to the right, it means we are subtracting something. If we are saying to the left, it means we are adding something to our x value. So that's why, for instance, here we say f of x minus 3. All right. So this here speaks to the right. To the right, we are subtracting. To the left, we are adding. To the right, we are subtracting. To the left, we are adding. To the right, we are subtracting. Hey. To the left, we are adding. All right. Yeah. So somehow me and you have to get it. Okay. So to the right, we are subtracting. We say minus 3. Then they said 4 units down. It means exactly what you are thinking. If you are saying something is moving down, then you are subtracting. If you are saying something is moving up, then you are adding. So there's no counterintuitive anything when we are moving up and down. But for when we are moving left and right, then you must say it is not what my mind would normally think. All right, because to the right, someone would think we are saying plus 3. But if we are saying to the right, you are saying minus 3. You are saying the opposite of what you would normally think. Hence, we speak about counterintuitive. Counter means against, and intuitive means thinking. So it's against normal thinking. To the right, we are subtracting. To the left, we are adding. To the right, we are subtracting. To the left, we are adding. To the right, we are subtracting. To the left, we are adding. Hopefully we get that. So let's go now to the actual function. This here is f. So let's rewrite negative 3 over. There we have x, we have minus 2, but since we said this is translating 3 units to the right, we know we are subtracting 3 from whatever is there in the denominator. That's very important because that speaks to the right. Then minus 4 means we are moving down by 4 units. So that means to the positive one that we have there, we need to minus 4. Okay. This is h of x. So therefore, let's go and write the final answer. We have negative 3 over x minus 5. Okay. And then 1 minus 4, negative 3. That is h of x. Okay. Surely, guys, that doesn't look that's not too shabby. Now, I know some people can simply move from writing down the function or just directly going ahead and writing down the function, because some people, they do stuff in their heads. So for instance, if you look at the question again, it says another function h is formed. So another function means it's a new function. It's a function that's not been there at the beginning. The only function we have initially is f. So they are saying another function h is formed. Now, in your head, you ask yourself, h is a new function. And then it's like, how is this new function formed? And they tell you, by translating. What is translation? Simply means movement. By translating f, moving f 3 units to the right. So if we are moving f 3 units to the right, what is actually happening, guys? What is actually happening? We are subtracting 3. Okay, so people usually just know if we are subtracting 3, what are we actually looking at? We are looking at the x minus 2 expression, because that's where the p-value is, which speaks to movement left or right. But if they are saying 3 units to the right, it means I'm going to actually be subtracting 3. So people usually do this mentally, and they write h of x is equal to negative 3x, and then they're like, okay, if it's saying it's translating f 3 units to the right, what am I doing? I am subtracting 3 from minus 2. So therefore I say minus 2 minus 3, which gives me negative 5 in the denominator. X minus 5. Then the further statement says, and 4 units down. Downward movement or upward movement will affect our constant term. So that means, what are we doing if we're saying 4 units down? It means to the positive one, we are going to subtract what? 4. Since the function is moving 4 units down. And then we get that answer, negative 3. So that's why h of x, when we write the new function, we know how it translates. So it's h of x minus 3 over x minus 5 minus 3. Okay. I hope we are going together here. I hope we are feeling this beautiful thing together, and it makes making sense to us. The next question, look at it. This next question says, for which values of x is h of x, the new function, less than or equal to negative 4? Hey, interesting question. For which values of x is h of x less than or equal to negative 4? So let's first unpack what they are actually asking before we dive in and ask and answer the question. This question is saying, for which values of x is what? H of x less than or equal to negative 4. Yes, Tati, it's grade 11. Okay. For which values of x is h of x less than or equal to negative 4? So in other words, what do we understand by less than? If we are saying h of x is less than negative 4, it means we are checking where h is below the line y is equal to negative 4. We are checking where h, meaning the function, where can we see the function being below? That less than means below. Below where? The horizontal line y is equal to negative 4. Where is the function h? Less than means where is the function of h below? Where do we find the function of h being below the line y is equal to negative 4? Okay. But also, this equal, we are not only looking for where the function is below, but the equal. Remember, guys, there's this equal, this line that's beneath the less than, which means equal. So we are saying less than or equal, less than or equal. But this equal means on the line y is equal to negative 4. So we're looking for two situations here. We're looking for where the function of h less than means where is that function below what? The line y is equal to negative 4. Or where, because of equal, this equal, where is the function h on the line y is equal to negative 4? So we are looking at the line and on the line and below the line, on the line and below the line, on the line and below the line. And we are looking for the x values that show us on the line y is equal to -4, which is the equal part, and below the line y is equal to -4, that is the less than part. Less than means below, equal means on the line, less than means below, equal means on the line y is equal to -4. So please take note, guys, because it is saying less than or equal to -4, we are looking where is the function of h. Remember, we just found the function of h, which is this one. So we are wanting to check where is the function below and on the line. Okay, which is a very, very key and important question. Okay, so the question then is, what do we do to answer this sort of question? What do we do? Right? So already, okay, what's nice is that we already know that, roughly speaking, if we were to just be rough about sorry guys, if we were to be rough about the function, okay, because for me it's nice for me to be able to see the function roughly. Okay, I would love to see this function roughly, the function of h of x, because I want you guys to understand this thing graphically as well, this question. All right, so if you go to the function, we know there's a horizontal asymptote. It's y is equal to -3. Okay, if I was sketching it, we have a vertical asymptote, which is x is equal to 5. Okay, y is equal to -3 and x is equal to 5. Then because a is actually negative, it means that the function will be found where? It will be found in the first and also in the in the second and in the fourth quadrant. That's where the function will be found. So I'm expecting that the function will be here somewhere, roughly speaking, and the function will also be here somewhere. Okay, roughly speaking. That's what we are expecting about this particular function. Now, remember guys, I spoke about the line y is equal to -4. So we know that there's the line y is equal to -3 where the function does not exist. But there's a line that is basically y is equal to -4. And what I want to do is I want to get some color pen. Yeah, sorry. I can get some, because I want you guys to see this. So let's just say we have the line y is equal to -4. Okay, because when we are looking at the question here that we are basically being asked, this would be like the line y is equal to -4, because remember they said for which values of x is h of x less than. So we are looking at the line y is equal to 4, and we are looking at where is the function below this line. What x values show the function being below this line, but also on this line, right? So it will become now important for me to figure out when y is equal to -4, what is the corresponding x value? I need to find what this x value is. So the only way to be able to find that x value is if I take the function of h, which by the way is that, okay? And I'm going to let y be equal to -4 and substitute here. So I'm going to do that because I want to find out what's the x value at this point. What's the corresponding x value that I get here? Because remember, they asked me for which values of x is this h of x actually found below and on this line y is equal to -4. So let's go ahead and do the maths as we usually do. Take the -4, we transpose it, it becomes +3. We get -1 is equal to -3 over x minus 5. Okay, so I took the -3, became +3, -4 plus 3 gives me -1. I have -3 over x minus 5 now. So I can use the LCD, x minus 5, multiply both the right and the left. So the x minus 5 and the x minus 5 would cancel here. And then the -1 times the x minus 5. On this side, -1 we distributed inside the bracket by multiplication. -1 times x is -x, -1 times -5 is +5, which is equal to -3. X is equal to -5, -3 minus 5, which gives us -8. And then the x value, we divide both sides by -1. We get x is equal to 8. So the corresponding y value, x value, where we have the function of h being on the line y is equal to -4, is x is equal to 8. So where x is 8, that's where the function is what? That is where the function, where x is equal to 8, guys. Okay, remember I just used the fact that y is equal to -4. I substituted y is equal to -4 for the hyperbola function, which is the h of x that I've gotten. I got a corresponding x value, which is what? Which is 8. So I know my x value here is actually 8. And what am I looking for, as I had interpreted earlier on? I'm looking for where the function of h of x is less than or equal to -4. What does the less than part mean? Where h is below the line y is equal to -4. What does the equal part mean? Where h is on the line y is equal to -4. So we know where the function is on the line y is equal to -4. We know the x value that shows us the function being on the line y is equal to -4. It is when x is equal to what? To 8. When x is equal to 8, the function of h is on, it's equal to -4. When what? When x is equal to 8. Then let's check, where is the function less than -4? In other words, where is the function of h below y is equal to -4? So you need to think that what's happening as the function from 8 onwards, what's happening to the function? Is it below the line y is equal to -4? So where x is greater than 8, as we move in this direction, where is the function? In other words, when x is greater than 8, what can you see? Is this function below this line y is equal to -4? Do you see that? Do you see that? Do you see the function of h being below, or is the function above the line y is equal to -4? Is the function above or below, guys? I'd love someone to comment in the comment section. What do you guys see? As when x is greater than 8, in other words, in this direction, okay, where is the function? Is it above or below the line y is equal? This is the line y is equal to -4. Is the function above or below the line? Okay, so Tati, thank you so much. Thank you so much. All right, it's almost as if that Tati number 1, I see there's a badge there. It's thank you for your participation there. Yeah, for a moment there I thought I was in ghost town, you know. I really hope people are grasping this. And really, guys, if you do find yourself not getting me, please ask questions so that I can actually explain. All right. So yes, when x is greater than 8, the function of h is actually is above the x-axis. So it can't be when x is greater than 8. Okay, so we need to then look what's happening on this side. In other words, what's happening when x is less than 8, and specifically less than 8 up until a certain restriction. In other words, between 5 and 8. Remember, the function does not exist exactly at 5, so we have to then be careful and say we are not including 5, but rather between 5 and 8. If you're writing it in interval notation, right, then you are writing it this way. Okay, 5 and 8. So we have already established that in order for this here h to be equal to -4, then we know that equal means on the line y is equal to -4. So which x value shows us the function being on the line y is equal to -4? It's when x is equal to 8. So that's why we know that we have to include 8 for the equal part to actually be true, meaning on the line y is equal to -4. Then for us to be able to speak about the function being below, where does it start being below? The minute we are less than 8. But it goes and goes until just after 5, after x is equal to 5. Guys, here we know it is 5, our vertical what? Our vertical asymptote. The function is below, but it is below only up until the x value that is after 5. On 5, the function doesn't exist. So we are not saying it's below or what at 5. That's why we are not including 5. So it's from 5 to 8. When x is 5, it does not exist, but just after 5 up until 8, exactly on 8, that's where we are able to meet this condition. The function of h is less than, meaning it's below -4, and it's also on, meaning equal to -4. So this is our answer. When x is an element of 5, why aren't we including the 5? Because remember, on the vertical asymptote, the function does not exist. So we can't speak anything about equal to 5. But we can surely say from 5, after 5 to 8. So we don't include the 5, but we include the 8, from 5 to 8. Where 5 is not included, but 8 is included. Or we could write our answer in this inequality form. X greater than 5, but less than or equal to 8. Right? So you have two ways of writing the answer. Interval notation, okay? Or you can do it in set builder notation, where it involves an inequality sign. Okay, right? So I hope those who are watching, if you have a question, I am waiting for you in the comment section to ask your beautiful, glorious question. I will be happy to entertain it. So that is why a sketch, guys, a sketch is very important, so that you can interpret, firstly, what does the question mean? Right? And that's why you see me unpacking this. H of x, okay, the new function, less than means what? Below what? This is an output for who? For y. So below the line y is equal to -4. Where is h below the line y is equal to -4? Equal, where is the very same function on the line y is equal to -4? Hence you found me substituting then y is equal to -4 for the function, so that I can get the corresponding x value, which is 8. So then I know, oh, on the on the y line y is equal to -4, this function is on there exactly where x is equal to 8. But then I need to check what's happening on the right. A, the function is above. What's happening on the left? A, the function is below. But up until when? You know? Up until when? Up until just after 5. So that's very important there. Okay? Very important there. So yeah, I hope we are all together and we are flowing very nicely. Now let me answer the last question, and then I will turn my attention to calculus grade 12 as per the promise. But yeah, guys, remember as well that in as much as people say in the comment section I said I'm going to do calculus, there is to some degree what I would want to actually continue doing as far as the continuation of the functions for the grade level, because it is custom tailored to some students that basically I am working closely with, and I have been working closely with ever since the inception of the live session. So there's an interest in that, and I often have conversations with those particular students, that relationship is there. So don't please guys, Tati, I don't go often. It just depends on the openness of my evenings, because I'll tell you this one thing, I'm a very busy guy. There's a lot that I do, and time is not really always available for me to do live sessions as I would like to freely do them. So I'll tell you this one thing, when the opportunity is there and the time is available, I'll do it, but if not, then I can't. So I can't really speak of a consistent time or a specific time or a set time. You know, I know people would love me to have a set time, and I can't speak of a specific grade when, but after I do these sessions, I do upload these sessions on my YouTube channel. Sorry guys, I just need to put down this phone a bit because something else is not going right now, and it is in need of my attention. It needs my attention. Okay, there we go. Sorry. Yeah. Okay. So just a sec, I'll be getting into the calculus for those grade 12 learners that want calculus to be done. Just hang on a sec. And hopefully you guys are getting taught as well. Like, I mean, at your respective schools, you know, it's not that you guys are coming here for the first time to learn things, but it's like you are getting taught as well. Yeah. And also, Kate, I had actually forgotten about the fact that I was going to do calculus today. And it has to do with the fact that it's been quite a crazy day for me today. So, yeah, sometimes my mind does not really work as smoothly as I would want it to. I forget certain things. I forget what I had said. Getting old. Thank you for the follow, Tati. Wow, finally, hey. You finally pushed the button. Thank you so much. I really appreciate that follow. Thank you for the follow. Okay guys, I'm going to do one last question for the hyperbola. And this question has to do with converting a hyperbola form of this nature to this nature. I don't know if you've ever seen a question of this nature, guys, where you have to convert a hyperbola of this nature to that form. Sometimes your hyperbola can be given in this form. And when you have it in this form, if you want to be able to write the equation of the horizontal asymptote, you won't be able to simply locate it. Okay? Faisal, you are funny. No, usually people convert from religions. You are very funny guy. So I'm guessing it's like converting religions. Convert this function form to this form. Okay, cheers buddy. Cheers bro. You're a funny man. Is Faisal by any chance? Too many Faisals. Faisal from Pakistan. A lot of people that just like hop on here. Or is it a Faisal that's not even Pakistani and it's just an adopted name there for the live sessions? Okay. Yeah. So like I was saying, guys, before I got disrupted by Faisal there in the comment section, if you're given a function in this form, you need to have the ability of converting the form to this one, right? I just want to show you one example. I just want to do one example for you guys, for y'all, quickly, and then I'll call it quits with hyperbolic functions for now. So let's say we have y is equal to 3x minus 5 over x minus 1. And then they say write down the equations of the horizontal and the vertical asymptotes. So you sit there and you look at this and you're like, how in the world will I be able to write down the equations of the vertical and the horizontal asymptotes when I'm given a function of this nature? Okay, and you ask yourselves a lot of questions and you're like, I don't know how to do this, and then like you're like, okay, I think maybe the vertical asymptote I'll be able to write, no problem, but what about the horizontal? Okay. And honestly, yes, you can be able to write the vertical asymptote, no problem. The only problem here will be the vertical asymptote. I mean, sorry, the horizontal asymptote, because the vertical is fine. Okay, the denominator there is still patterned after what you would basically utilize to write the vertical asymptote. Does anyone want to tell me what the vertical asymptote would be of this function? The vertical asymptote, what would it be? Any chances? Anyone who wants to be the hero of the day? Okay, I'm guessing no one wants to be the hero of the day. Okay, so let me just write another question that we can look at. Okay, and then another one that we can look at. Okay, so if you look at these questions, this here is probably the most basic. This is from basic. This is intermediate, and this is advanced. Or maybe these two are actually in the same level. These two. So let's start at basic. All right, let's start at basic. So what do we do first and foremost with questions like this? Y is equal to x minus 5 over x plus 3. How do we convert this form, binomial over another binomial, to a form like this? Because this is the general standard form that we all love and appreciate for a hyperbola. But how do we convert this form to that one. Okay, so hopefully, I don't know if there's anyone who would want to actually come on and guide us in being able to do to convert the form to the other one. Anyone who's feeling lucky? Ndando, maybe Lendery, Mel, maybe Mr. 909, maybe Elijah, maybe Automotive Channel, maybe Jupiter, maybe you feeling lucky, or maybe it's Faisal, the Faisal one. Who would like to help us out? Y is equal to x minus 5 over x plus 3. So what you do, guys, is very nice, very simple. You see this guy, you see him, this guy, all right? Sing as though the coefficient, and this is the thing here, the coefficient of x in the numerator is 1. So when the coefficient of x in the numerator is 1, it's more straightforward, it's very simple. Okay, so what we try and do first and foremost, you see this x plus 3, we need to make sure that we get that same x plus 3 in the what? In the denominator. I mean, that's in the denominator, in the numerator. This same x plus 3 in the numerator, we need to get it to be in the denominator, we need to get it in the numerator. This x plus 3. Okay. You see now this x plus 3 over this x plus 3, it will give me a what? An actual value, which is 1, because something divided by itself gives me 1. Then you need to ask yourself a question. What constant value can we add to what? To 3, to positive 3, to get minus 5. So what can we add or subtract? Let's say add or subtract. Okay, because it will depend on what we have. So let me just rewrite this again without the brackets. So what we first do is that since we have x plus 3, we are going to immediately write another x plus 3 in the what? In the numerator. Remember, we had x minus 5. So the question is, what can we add or subtract to 3 to get negative 5? Because I need to write that value after this positive 3. Okay, so what can I add to 3 or subtract from 3 to get negative 5? That is what I'm asking. Okay, so here I need to add a certain number, which when I add or subtract to 3, it will give me negative 5. What, guys, is that number? Please tell me. Please, in the comment section, help me out. What can I add or subtract to positive 3 to get negative 5? Because what I want to do is I want to still retain this x minus 5, the answer at the end. And the reason why I'm asking you for the number which I can add or subtract to 3 to give me negative 5, I still want to have the expression that will give me x minus 5 in the numerator. Okay, because that will mean nothing has changed. So I need someone in the comment section very quickly to tell me 3 plus what or 3 minus what gives me negative 5, because I'm going to write that number here in that box. 3 plus what or 3 minus what gives me negative 5? What can I add to 3? Or do we even use the word add? What can we subtract from 3 to get negative 5? 3 plus or 3 minus what gives you negative 5? I'm waiting. Is everybody that's on this comment section sleeping by any chance? You guys are gone. You are in Tongo land as we speak. you are meeting those who have long passed. What's happening, guys? Why is nobody telling me anything? Should I end this live? Because lack of participation means no one is here, so I'm going to end the live, guys. I think it's time for me to say goodbye to you guys, because no one is answering my question. Okay, no one. It's like silent here. It's very concerning. Silence means concern. Silent means there's a problem. Okay, so I repeat again. We have x minus 5 over x plus 3, right? You see that? Now, all I did now is I took this x plus 3 as it is, and I simply wrote the same x plus 3 in the numerator. Now, I still want to get a negative 5 for my constant term. So my question is, what do I add or subtract to plus 3 to get negative 5? What do I add to 3? Now we are going back to primary, guys. Hey, people are, hey, son. 3 plus what gives you negative 5? Was I ask it that way explicitly? Faisal said something in the comment section. You see, now I need to check with everybody else how true or how false is what Faisal is saying in the comment section. Negative 8. Okay, so hopefully we can see 3 plus negative 8, guys, gives you negative 5. Okay, right? So what do? We write x plus 3 in the denominator, and then we reproduce that same x plus 3, and we write that same x plus 3 in the numerator. Then we know we had negative 5 as our second term. My question then is, what do we add to positive 3 to get negative 5? So yes, you guys are right, it's minus 8. At least Faisal is right, it's minus 8. So if I rewrite this is x plus 3 minus 8 in the numerator. And really, if I say 3 minus 8, don't I get this negative 5 back? Indeed, I do. Okay. Now, we can write that over x plus 3. Please take note, guys, of what's happening here. Now, I can separate x plus 3 and write it over this x plus 3 like that. Then the negative 8, I can also write it over x plus 3. Now you are going to be asking how. Remember, guys, if I put brackets around this x plus 3 and I ask you in the numerator, how many terms do I have? Okay, remember, a bracket combines 2 terms so that this becomes 1 term. So if I asked you how many terms there are in the numerator, you would say there are 2 terms. Okay, and then if I ask you in the denominator how many terms, since there's a bracket around x plus 3, you would also say there is 1 term in the denominator. So what I can do then is I can split x plus 3 minus 8 over x plus 3 and write it as x plus 3 over x plus 3 minus 8 over x plus 3. I hope you guys understand this. Then what happens? What is x plus 3 divided by x plus 3? It is 1 minus 8 over x plus 3. Now I'm sure you can see that now we can conclude and say y is equal to, the fraction must come first. We have minus 8 over x plus 3, followed by what? This one, it is positive 1. So this is the function, guys, the hyperbola function, when we have actually converted, or this is how we convert a hyperbola function of this form, y is equal to x minus 5 over x plus 3. We can convert it by, like I said, we ensure that we utilize the denominator expression, we rewrite it or reproduce it in the numerator. Since we have x plus 3 in the denominator, we write x plus 3 in the numerator. Then after that, we ask ourselves, what constant term can we add to positive 3 to get back that constant that we initially had, which is negative 5? What constant term can we add or subtract to positive 3 in the numerator to get back that negative 5 that we had initially in the numerator? So we know that we can subtract 8. Very important, because 3 minus 8 will give us back the negative 5. Step number 2, you put brackets around the x plus 3 and the x plus 3. Why? Because in the numerator you now have how many terms? 2 terms. Why? Because x plus 3 in a bracket is 1. Minus 8 is your second term because terms are separated by a plus and a minus sign. In the denominator you have x plus 3 as well in brackets. Then what you can do now is you can split. Since you have two terms in the numerator and 1 term in the denominator, you can split the 2 terms so that they both adopt the denominator x plus 3. So it's x plus 3 over x plus 3 minus 8 over x plus 3. What's x plus 3 divided by x plus 3? It is positive 1. The negative 8 over x plus 3 is our second fraction term. And then we rewrite the order so that we can get the form of the hyperbola function that we love and know. So y is equal to negative 8 over x plus 3, rightfully so because it's negative, plus 1 because the 1 is positive. Okay, so that's how we convert, guys, that form that we have into the form that we love and appreciate. I want to look at another one now. Let's look at another question, this one. This time round, it's y is equal to negative x minus 3 over what? X plus 1. Okay, so let's look at this one. Slightly complex because unlike the previous one where the coefficient of the x term in the numerator is positive, this one has a negative coefficient for our x term over x plus 1. So now we have to again convert this form into a form that we all love and know. Okay, so then the question in our heads that's probably dawning is, what do we do with a function of this nature when it is like this? What do we do? So once again, in the denominator we have x plus 1. So obviously what we want to do is we want to fashion what we have in the denominator so that we have x plus 1 as well. Okay, yeah, but now there's a dynamic that we are seeing with this particular situation. It's a dynamic that we are seeing with this particular situation, because if we write x plus 1 and then x plus 1 at the top, someone is probably sitting here and asking themselves, but then so how are we going to get minus 3 and also at the same time be able to retain the negative sign that we are there? Because here both of these, if we pattern it like this, it's going to be x plus 1 over x plus 1. So what do we do in this particular situation? Okay, right now, for some of you, maybe if you are looking at this, you are thinking, Maybe say, can't we then maybe take out a negative like this and then write over x plus 1? Is that perhaps going to be able to maybe assist us and help us in our endeavor to be able to write the answer? Okay, and probably not. Okay, probably not.